2, 1.
Hi class. So it's our last note here, and I couldn't quite get my webcam working, so you don't get to see my beautiful face in the corner, but I'm sure you can get by just hearing my voice, right? Anyways, so here we are. We're at the very end of trigonometry, and we're going to be solving problems now using everything that we know. So basically, there's no new formulas. It's just taking a look at a situation and thinking, what can I do? So how can I take what I've learned and apply it to solve a problem? So this is really what we learn math for, is this type of problem solving. It's not quite as good problem solving if you're like in a cosine law section and you get a word problem, then obviously you need to use the cosine law to solve it. So this is more authentic problem solving, where you have a problem and a whole bunch of different ways you can solve it. And so it's up to you to find kind of the most effective way and the most efficient way and also correct way of solving it. So here we go. So first of all, just a reminder that solving a triangle means finding all lengths and angles. And when you're solving a problem, you always want to draw a diagram. So I've created this trig toolbox for you. So I would encourage you to pause the video at this time and then copy everything down and then just listen as I talk about it once you have that done. So the first thing you want to identify when you get one of these problems is it a right angle triangle or is it not a right angle triangle? So if it's a right angle triangle, it's simplest to use either Pythagorean theorem or SOHCAHTOA. So using the sine, cos, and tan ratios or Pythagorean theorem. If it's not a right triangle, you can't use any of these relationships. You can use sine law or cosine law. Okay? And then you'll also need to remember your angle relationships to solve these problems. So the first one being that 3 angles add up to 180 degrees. The second one being here that any angles along a straight line will add up to 180. So in this case, that's just saying A and B. So A plus B equals 180 degrees. So anything along a straight line adds up to 180. Also remember the Z pattern. So if you have 2 parallel lines, and one that goes through them, then these 2 red dots are equal to each other. Okay, and it's very important to remember the angle of elevation and the angle of depression. So the angle of elevation is between a horizontal and the incline there. So this would be the angle of elevation right in here. And the angle of depression is when you look down, but it's always against a horizontal, okay? It's never against a vertical. It's always against a horizontal. And then using the Z pattern, these 2 green dots are equal. So if any of these areas are giving you trouble, you don't know how to apply any of these, you should go back and at least rewatch 1 or 2 examples in any of the previous videos. Okay, I'm not going to be re-explaining how to use any of these rules or laws. But I'll just be assuming that you know how to use them. So that's the beauty of having the videos, is that if you need a refresher, for instance, how to apply the cosine law, then you can just go back and you don't need to watch the whole video. You can just maybe watch 1 example. Okay? Now, if any of these problems are giving you trouble as we go along, please make sure that you put a star or an asterisk or a question mark on the side of your page and you're asking me about it tomorrow. Okay, it's your responsibility in the flipped classroom to make sure that you are getting the help that you need when I ask, were there any questions? Okay, so a chandelier is suspended from the ceiling by 2 chains. So let's draw a ceiling here and then the 2 chains coming down. So here's 1 chain and here's the other chain. Okay. 1 chain is 46 centimeters long and forms an angle of 60 degrees with the ceiling. Oops. Okay, and then it says the other chain is 64 meters long. Sorry, 64. Okay, it's doing this thing again. Okay, let me just a second. Oh, fix it, don't worry. I found a way to do this the other day. So 64. Okay, so what angle does the longer chain make with the ceiling? So it wants to know this angle here. Okay, so we want to solve for this angle. So the first question is, do we have a known ratio? So, well, first of all, you notice that this is not a right angle triangle, okay? So we can't use SOHCAHTOA. So now we're down to using either sine law or cosine law. So I'm going to say that we want to use sine law if we can. So there is a known ratio here. So notice that we know that this is 60 degrees and we know that this is 64. So we can use the sine law, okay? So use sine law. I'm recording a video right now. Say hi. That was Mr. Bolts. Okay, so our unknown is A, so we would do sine of A divided by 46 equals sine 60 degrees. I like this pen, it's cool. Over 64. Because there's our known ratio, 60 degrees over 64. Okay, so you can solve for sine A by multiplying 46 up top, and you get 0.6 to some long decimal that you'll get in your calculator. And when you find angle A by inversing that sign, it rounds to 38 degrees. So because this is a word question, we need a word answer. So we need to say, therefore, the other chain makes 38 degrees with the ceiling. Okay, so you can fill that in, but make sure you have a sentence. Okay, next question, example 2. Rashid is building a house and he needs to know more information about the roof's design. The base of the roof, let's draw that. The base of the roof is 12.8 meters wide, and the rafters are here and here. Okay, so this is 12.8 meters wide. And the rafters form angles of 48 degrees and 44 degrees. So this is 48 degrees, and this is 44 degrees to the horizontal. How long to the nearest tenth of a meter is each rafter? So we can call this X and this Y, and that's what we want to solve for. Okay, so again, this is not a right angle triangle. So can we use sine law? So we always try to use sine law if possible, but for sine law, we need a known ratio. So right now it looks like we don't have a known ratio, but we can find that the top of the roof here, its angle is 88 degrees by adding up 48 plus 44, and then plus this angle has to equal 180. So T was just 180 degrees minus 48 degrees minus 44 degrees equals 88 degrees. So now we have our known ratio here. So we can use the sine law. So let's find all these colors. So pretty. So I'm going to find X first. So X over sine 44 degrees. Okay, so here they're across from each other, equals 12. Oh my word, now it's doing this too. Got it, solve the problem. Okay, 12.8 divided by sine 88 degrees. Okay, so then you arrange and you multiply and you use the sine law and you get approximately 8.9 meters. Okay, now we use the sine law again to find y. So y over sine 48 degrees, set it equal to our known ratio of 12.8 divided by sine 88 degrees. You go through and solve this, and you get approximately 9.5 meters. Alrighty. Again, if you're having trouble knowing how to use the sine law, you can go back to that video. Example 3, Tyson is doing a project on the seasonal change in the size and flow of a river near his house for environmental studies class. Among the statistics he must compile is the width of the river at different times in the school year. So there is a 130-meter building on one bank of the river. So here's the building. And Tyson, so then here's the river. And then Tyson is standing on the opposite bank. Here's Tyson. I'm assuming he's not 130 meters tall. And, sorry, I lost my space. And the angle of elevation to the top of the building is 42 degrees. So remember, angle of elevation is the sight line up. So the angle of elevation would be here against the horizontal. So we would label this here as 42 degrees. Okay. How wide is the river to the nearest meter? Okay, so this is a little bit strange because they don't tell us how tall Tyson is. And I understand that that's a little bit of a, it's a flaw in the problem. So when they don't tell you that, we're just going to assume that he's right on the ground. Okay, so we're going to assume now that this is the river. And he's measuring the angle of elevation from the ground. It doesn't say that it's from his sight level. It just says that the angle of elevation to the top of the building is 42 degrees. So the only option we have is to assume that that is from the ground. So then this distance here is 130 because we know that's how tall the building is. Okay, so you have to be able to interpret the questions. Okay, so notice that this is a right triangle, okay, because we can assume this building is standing straight up at 92 degrees. So notice that this is a right triangle. So therefore, I'm going to use SOHCAHTOA. SOHCAHTOA, that's what that says. All right, so let's remind ourselves how to do this. Okay, we want to know the width of the river, so W. Okay, so in reference to this angle, we have opposite and we want adjacent. So we have opposite, want adjacent. So O and A, that's TOA. So we're going to say that tan of 42 degrees is equal to 130 divided by W. So W is equal to 130 divided by tan 42 degrees. And we put that through our calculator and we get approximately 144 meters. So then again, we put a nice therefore sentence. Therefore, the river is approximately 144 meters wide. Okay. Final question. Two tracking stations 20 kilometers apart measure the angles of elevation to a rocket that was launched to the east of both stations. Okay, so we really need to get good at being able to draw accurate pictures for these types of questions, okay? So two tracking stations are both looking at a rocket that's to the east. So remember, never eat sour watermelons. So the tracking stations have to be over here and the rocket is over here. So you have some kind of, we can put a label here, some rocket over here. Okay, and our tracking stations are down here. Okay, we'll make a line between them. We'll say that this is tracking station A, and this is the software I tell you. Okay, this is tracking station A, and this is tracking station B. Okay, and they're 20 kilometers apart. All right. B is closer to the rocket as I drew. So the rocket is 23 kilometers directly above the ground. So that means that this distance here is 23. Okay. From station B, the angle of elevation is 75 degrees. So from here to here, okay, so we can also extend this line. Oops. We can also extend this line here. Okay, so from here to here, the angle of elevation is 75 degrees. Okay, how far is the rocket from station A? So we know how long A to B is, but we need to figure out how long A to G is. So how far, sorry, A to R. How far is the rocket from station A? So we need to find out the distance from A to R. So let's draw that in as well. Okay, so we actually have three triangles going on, okay? So let's just make sure you have an understanding of all the triangles that we see here. So G stands for ground. So we have the triangle ARB, which is not a right triangle, okay? It's just a non-right triangle. Then we have the triangle RBG, which is a right triangle. And we also have the triangle RAG, which is a larger right triangle. So we need all of this to be able to find us AR. So this is what we want. So let's label it X. Now, there's many different ways to solve this problem, okay? You can use this RBG to find how long RB is, and use this 75 degrees to find out how big this angle is, and then use cosine law or sine law in this big triangle. Okay, I can also use SOHCAHTOA to find how long BG is, then use right trigonometry with this to find the big thing. Okay, there's lots of different ways to find X. So what I'm going to do first, the way I'm going to solve it is by looking at ABR. So I know that angle ABR inside here, this has to be 105 degrees. Okay, because this angle and this angle have to add up to 180. So angle ABR is equal to 180 minus 75, so 105 degrees. Okay, now I can find how long BR is using SOHCAHTOA in this right triangle. So BR, so the length of BR is equal to 23 divided by sine 75 degrees. Okay, if you're not sure how I got that, I'll put that on the side. That's just because sine of 75 degrees is 23 over BR. So I just rearranged it to get this expression. Okay, so BR then is equal to 24 meters. Okay, so now I know that this is 24 meters, okay? So now I can use the cosine law to find X because I know this is 20 and this is 24 and this is 105, so I can use the cosine law. So it would be X squared equals 20 squared plus 24 squared minus 2 times 20 times 24 times cos 105 degrees. And when you go through and solve this and square root it, you get that X is equal to approximately 35 kilometers. And that's your final answer, so you can write a nice little sentence. Okay, so you'll notice in this video, I didn't really go into how to use all of these formulas. Again, I went into that at length in the other videos. This is just about how to look at a problem and choose the best way of solving it. So you really have to think about yourself, you know, like when a carpenter goes to fix something in a house, he has a toolbox and he looks inside it and he says, is a hammer best to do this job, or a wrench, or what's the best tool that I need? So your job as mathematicians is to say, look at the problem, draw a picture and say, do I use sine law? Do I use SOHCAHTOA? What is the best thing I can use to solve this problem? And then you go through and execute and solve the problem. And of course, the carpenter, when he's done, looks at his work and thinks, is that the best work I could have done? And so will you as mathematicians. Okay, guys, so thanks for watching. I hope you learned lots.